You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this. So back in the distant before times of 2008, a team of scientists led by Tullen Onstadt decided to look for life in a strange place. They took a look in a South African gold mine that was almost 2 miles deep.
Fun.
Gold
Love
mines,
that.
yeah, gold mines are like metaphorical, well, gold mines to scientists because digging underground is super expensive, right? If you wanted to bore a 2 mile deep hole in the earth for your research, you better have some serious funding behind you.
That's really freaking deep.
Yeah, that's really deep and also very expensive. I was kind of curious how expensive, so I actually spent a chunk of my day trying to track down, like, what does it cost to drill a research well like that if you were to do it. I did actually find a paper where someone described how much it costs, and it ends up costing about $1,000 per foot. Per foot. Okay, now, obviously not the first foot, because I'd do that for, $500. But, on average, $1,000. So if you have a 2 mile well, that's or borehole, that's 10,000 feet approximately. So that ends up being
that's like
$10 million.
That doesn't even account for like how wide it has to be.
Oh no. I mean, but this is probably for like a borehole. Usually is like not real wide, maybe 8 inches, 4 inches, 6 inches. You're not. This is not a huge. You're not making a mine shaft. This is just a exploration well or something like that. So yeah, about $10 million if they had done this. So right off the bat, they saved $10 million on their research, which bravo to them.
Good job.
Now, you can imagine one catch you might encounter is that a mine is not sterile. You got workers coming in and out, bringing things in on their clothes, might be eating down there, certainly coughing and blowing their noses, going to the bathroom, bringing in equipment. Basically they're contaminating the environment just by their presence. Now, a lot of the microbes they're going to bring down are going to be short-lived because deep underground is not the environment they evolved to live in. These researchers, though, to be clear, were not just like swabbing the walls and looking in puddles in the floor that people were walking through. They were taking samples of water from deep within the rocks themselves. Okay, so this is, I guess, called groundwater, but at this point it's 2 miles underground in these cracks, and they were sampling some of this water they were finding.
Where are you going with this?
I know. Where am I going with this?
What's the temperature like down at that level?
Well, I don't have that information, but I'm guessing it's getting a little warm. The team of researchers, they found these pockets of water inside these cracks in the rocks, and they tested and they found microbes living inside that water. Now, what is really strange is that they found just one single kind of organism. This is absolutely unheard of in microbiology. Organisms do not live completely alone as the only living thing in their ecosystem, and that's what was going on. And this goes against everything we thought we knew. They found a bacterium. They eventually named it Candidatus desulfuridis audax viator. I think I said that right.
Try it.
Nope, I said it once. Now, I love learning the origin of names like this. Like, what the heck is that, the ending there, audax viator? It turns out it's a really poetic answer. It comes from a Jules Verne, one of Jules Verne's most famous books, Journey to the Center of the Earth. In the book, Professor Leidenbrock finds a secret inscription in Latin, and I'll tell you what it says in English. It says, "Descend, bold traveler, and you will attain the center of the earth." And audax viator is bold traveler in Latin.
Oh.
So it's kind of cool that they named this creature that.
That is
now
pretty cool.
For me, this is where the story gets I think, really interesting. I mean, it is
This
very
is
cool.
where this is where nature laughs at your concept of knowledge. Your
My concept
categories,
of
it
what's
waves at
normal.
you.
Yeah. It's very cool they found this microbe at all. But if you find a bacteria living in a completely self-contained ecosystem, it makes you wonder, like, what on earth is it doing there? And more importantly, how is it surviving? Right? There's nothing.
What's it eating? How is it not drowning in its own
Yeah,
waste, basically?
exactly. So now
Autocannibalism.
I previously talked about mitochondria, which evolved from bacteria that use oxygen for respiration. So we know using oxygen to sustain life is possible, but there is no dissolved oxygen in this water at all. So you're not going to
Whoa.
have any. You're not going to have any chance to, like. This isn't a bubbling brook. This is stagnant old water that they estimate had basically been down there for about 3 billion years. Okay,
3 billion-year-old water.
not fresh
Just a little
water.
while. Just a tiny bit.
Yeah.
Sure.
There, of course, this might be confusing for some people because you go, wait a minute, isn't there oxygen in water? It's made out of hydrogen and oxygen. But what you need in order to use it is dissolved oxygen. You can't usually just get that oxygen out of the water and break down the bonds that make it
That
liquid
bond
water.
is so strong. Yeah.
So, I also mentioned deep water bacteria that were using nitrates instead of oxygen to survive in one of the previous shows. And Victoria even mentioned deep sea hydrothermal vents where bacteria use chemosynthesis to get energy. So we know there are different ways to make it work. So Rachel and Victoria, I put the question to you, a question these researchers needed to figure out, which put bluntly is, how the hell do these bacteria survive down there in an environment with no light, no oxygen, no fresh influx of water, and they are the only organism present, the only living thing in an otherwise hostile environment?
What kind of rock is it?
I don't know the exact type of rock. This is going to be probably like this is me just speculating here, like a volcanic rock. This is a gold mine, so and it's 2 miles underground, so it's probably not like a sedimentary rock or anything like that. But I don't actually know.
Probably metamorphic.
Yeah.
Some kind.
Autocannibalism.
There's an idea, autocannibalism. Okay, it's tough, right?
I have
Yeah.
no idea. Yeah.
Is there some kind of like dissolved minerals in the water that
Okay, yeah,
they're
yeah, there are.
using?
Good. Let's think
Yeah.
about it. There's basic
Eating
elements.
the rock.
We know there's basic elements needed for respiration. We know from the previous stories we've done, there's a few different chemical ways to make respiration work, but you absolutely need at least the most basic elements. So
Carbonates.
it turns out the microbe does have genes that allow it to split carbon
Okay,
from
sorry, go.
carbon dioxide in the water from dissolved minerals in the rock, like Victoria was talking about. So gold star Victoria. It also has, it has genes for doing the same for nitrogen. So, like in my previous story, I'm assuming, I couldn't find any information on this, but I'm assuming it's using nitrates in respiration instead of oxygen. So that's pretty cool. But what about hydrogen? Because you got to have some hydrogen too. That's one of the complex things that goes on in normal respiration. That turns out this microbe, can't do that. It can't just there's no magic way to get hydrogen. So where's it getting the hydrogen? The answer is pretty wild. The rocks underground, turns out, contain natural amounts of uranium, thorium, and potassium. Do you know what those all have in common?
They're radioactive.
They are
Yeah.
all radioactive, yeah. So the
Is it
radioactive
glowing?
decay, no, the radioactive decay of these naturally occurring minerals causes the breakdown of the water, which frees up hydrogen, which is one of those necessary elements of life. So the radiation also allows for the production of sulfur compounds, which are serving as a high energy food source. So these bacteria are completely dependent on nuclear radiation for their survival.
That's
In
crazy.
fact, yeah, knowing this, other groups of scientists have studied groundwater from deep nuclear weapon test sites underground and found the same bacterium present in the radioactive water. The same bacteria has in fact now been found deep underground in sites around the world, in mines and boreholes and other places. And one of the weird things is that all the samples are genetically or nearly identical from around
Oh
the
my
world.
gosh.
So this
That's
bacteria
insane.
is living in water that is, like I said, about 3 billion years old. And the fact that it appears to be the same around the world means that it likely existed back when all the continents were all connected as part of Pangea.
Wow.
So the age of the water may actually be a good way to age the bacteria. Going back to episode 1 of the show, this bacteria is a true living fossil, which is what I talked about in the very first episode. The bacteria may be a look at what some of the very early forms of life on Earth actually looked like. And by studying them, we can see how the basic elements of life were able to come together, even without some of the elements that we consider so important to the forms of life that we're more familiar with today. So that is just super cool. Of course, astrobiologists are also really excited about this because it shows that life is possible in yet another form that gives us hope of finding interesting forms of life on other planets and moons in our solar system. So this is a super cool story. When I saw it, I was like, oh my gosh, I gotta talk about this. The one little catch is that sometimes you'll see people here and like, oh, like they are feeding on the radiation, and no, they're not. They're not feeding on the radiation. The radiation is creating conditions in the environment that they are able to use to help them survive, which is super cool.
Yeah, the radiation is breaking down as naturally as it can, and as it does that, it's breaking up the water, which allows hydrogen. Yeah.
Yep. And it's has allowed this life form to thrive.
That is just nuts. Thank you, Kirk.
No problem. We're going to take a little break, and we'll be back with Rachel.
All right. This week, kind of sort of going off of Kirk's that he just talked about. Not
What?
really, but a little.
Okay,
in
I'm intrigued now to see where this is going.
Minuscule part.
Oh, I see.
We're
going small?
No, we're not going small at all. So
How about I just shut up and let you talk?
So this week, what I'm going to be talking about is the Alsace. Any ideas what that is?
Wait, this is ringing a bell. What is Alsace?
Sure does ring a bell.
It better ring a bell.
It's a moose.
It is a moose. Good job, Victoria. So
Yay.
I said it's minusculely similar because you talked about what is potentially one of the oldest things ever. Potentially a 3 billion year old organism. And this is one of the oldest deer that we have on the planet. It is, well, not oldest deer, but it is one of the last living, it is one of the last living Ice Age megafauna.
Okay, so one of the oldest extant Cervidae species.
Exactly.
Blah, blah, blah.
That was so much science words.
That made it so much clearer to our audience, you know.
Right. So it is the largest member of the deer family. It is also the heaviest, okay? It does occur not just in North America, but throughout the Northern Hemisphere. In Eurasia, it's called an elk.
This
so
is
it's
very
not
confusing.
a moose over there.
So
Isn't
confusing.
It? Why don't they just call it a moose? So it's been around since the early Pleistocene, which is about 2.5 million years or so ago.
Right, okay.
And there's a couple of things. Just moose in general, I always find fascinating just because they're so big. Like you always think that you know how big a moose is, and then You really don't.
They're so big.
They're so big. So on average, an adult moose stands 1.4 to 2.1 meters high at the shoulder. Okay. So that's 4.6 to 6.9 feet high at the shoulder.
Mm-hmm.
Right.
Okay.
That's not counting the head and the antlers.
That is not counting the head and the antlers. So
Okay, give us the total then. What are we doing?
the total height, typically a bull or a male moose, I'm going to call it a moose, I'm not going to call it an elk, is 1.2, which is, this is the antlers and this is the head and the antlers.
Okay.
They are about 1.2 meters and 1.5 meters like tall. So that's 3.9
above
feet.
what you already told us.
Above what I already told you.
Okay.
Or 4.9 feet. So like that's
So it's like 11 feet tall.
It's like 11 feet tall. Yeah. So it doesn't, that's the hard thing. They don't have like total heights when I was doing a lot of research, because a lot of times, especially for like horses and deer and everything gets measured at the shoulder.
Right. Never mind the fact they have like almost 5 feet of stuff above the shoulder.
Right, exactly. Just ignore that. It doesn't matter, right? It's fine.
It's whatever, you know.
Well, if they lower their head, then they're shorter. I mean, geez.
Yeah, there you go. There.
Technically, right. These moose, these deer, they normally weigh anywhere from 441 pounds to 1,543 pounds. Okay. Now this is both
that
for
is terrifying. Now
Isn't
imagine
it?
your car hitting those legs, which are
See, that's the
above the
thing.
height of your windshield.
Exactly. That's why you don't want to hit a moose, because the moose is going to be fine. The moose will walk away. You are not. That you are going to 100% just be plowed into by that moose.
That's 1,000 pounds through your windshield.
Yeah, I don't think the moose is going to be fine, but you're definitely not going to be fine.
Yeah. Well, sometimes the moose will be fine. It depends. Generally speaking, so when you think of a moose, you think of like a male moose with their antlers. And I'm doing a hand motion.
Let the record show that let's see how to describe this. Rachel has her thumbs on the side of her head, and she's waving her fingers up above her head. Then,
well,
in the international sign for moose,
as
or elk or elg if you're
Norwegian
out east.
I mean, this is what they did in the Princess Diaries. So. But generally speaking, like a male or a bull moose, like they have these big antlers, right? Which we just talked about how big they are. But they're called palmate antlers rather than like their twig-like antlers that you see on like white-tailed deer.
With all the tines and whatnot.
With all the tines and everything. Because they're open hand-shaped. So it's a good sign for,
Moose.
So generally speaking, they live in boreal forests or temperate forests in the northern hemisphere. In the lower 48 states, Maine has the most moose.
Way to go, Maine.
Go Maine. They generally feed on terrestrial and aquatic vegetation, so they only eat on plants. They lack upper front teeth. They don't have any. They have 8 sharp incisors on their lower jaw. They have a really tough tongue and lips and gums on their lower jaw, but they have a really sensitive top upper lip. They have 6 pairs of large flat molars in the back, and then 6 pairs of premolars to help grind up all of their food and their woody stems and everything. They are a solitary creature, which is strange because most deer are in herds. Generally speaking, moose only come together to mate. But what I really wanted to touch on and what makes moose even more strange are some of their predators. Okay. So
Okay.
their main predators now are wolves, bears, humans. They also used to be preyed upon by Siberian tigers. But if moose weren't terrifying
Sorry,
enough,
Siberian tigers?
Siberian tigers,
Wow.
right?
I don't picture that, but okay.
No, no one, you don't really picture that, but that's what my research said. Most of the time, moose really do, like, they're good at, like, swimming and everything, and we know they're big, and we don't really picture it. Their primary marine predator is an orca whale.
Oh, wow.
Wow.
Uh-huh.
I guess, sure.
They get out deep enough that they
Yeah.
will be preyed upon by pods of killer whales.
Yeah.
I didn't know
Man.
moose went into salt water.
Yep,
Yeah,
on the
wow.
eastern coast of like Canada or the northwestern coast of North America. They'll be swimming out between islands, and they can be preyed
Okay.
upon by pods of orca whales.
Or swimming through like a bay or something like that.
Mm-hmm.
I can
Yeah.
see that.
Which is
Wow.
something that I learned about fairly recently, and I was just like, what? There's actually also been one documented instance of a moose being eaten by a Greenland shark. So,
Oh boy. Wow. That
so
is
they've
cool.
been
Just
around
to tie
a
some
long
subjects
time.
together.
Just to tie it together a little bit more. That's all I have for you today. It's a little short, but moose are crazy.
That's cool. I have eaten moose when I was in Norway. So my family in Norway served us sloppy moose,
How was
which
it?
is sloppy joes made out of moose meat. They had just been out hunting and had gotten a moose. So
Oh man, at the end of the episode, I have something I want to read into the record. Maybe we can have it as a bonus.
Ooh.
all right, stay tuned. Oh boy. All right. Well, we'll go.
Yeah,
go to
next
break
it's
and then-
Victoria.
Yeah. Looking forward to it.
All right, we're back, and I'm last today, but not least, I hope.
Never.
So this week I want to talk about a recent scientific discovery. And like many of the best scientific discoveries, this one came when chance favored the prepared mind.
Awesome.
I got this story from a New York Times article from March 8th, 2021 by Annie Roth, and also from the scientific study on which it was based by Sayaka Mito and Yoichi Yusa. I'm not going to say the name of the study right now because it would kind of give away what I'm going to talk about.
Okay.
Excellent.
So Sayaka Mito is a graduate student in Japan, and she works in a lab that studies sea slugs. And in particular, Elysia, which is a genus of sea slugs. They're in the parlance of scientists, these are marine gastropod mollusks.
Uh-huh.
You know,
Mhm.
I think slug
I'm
is
so
such an
intrigued.
ugly word,
Yeah.
isn't it?
Yeah, it sounds so like slug.
Yeah, everyone pictures like the garden slugs, you know? and
Exactly.
they're
What
way
would you
more
what's your
fascinating.
preferred term, Victoria?
Well, I don't know. I mean, marine
Gastropod.
gastropod mollusk doesn't exactly roll off the tongue, but
Yeah.
at least it doesn't make you think of a slimy, nasty garden slug. But
I mean,
many-
gastropod literally means stomach foot, so that's not real.
Yeah.
It's not a big improvement.
Hell, let's call them wonder mollusks.
There you go. Wonder
Ooh.
mollusks. Wonderful.
I'm here for a wonder mollusk.
Many sea slugs actually can be extravagantly beautiful. There was a picture I saw when I was doing the research of this, of one that was all like frilly and multicolored, and it was actually
They're
called, I think, like a
gorgeous.
lettuce sea slug, 'cause it looked like frilly lettuce. Anyway, that's not the one I'm talking about today. But anyway, Mito was looking around at her lab's various sea slugs one day, and she noticed, to her shock, that one of them had been decapitated. Yeah.
Sounds like a
Uh,
nightmare.
Yeah, but okay, gets weirder. The head was still
Was
moving
there? Hold on.
around.
Was there a sand striker worm hiding in the cage or the tank? Because that would just tie all of our topics together so nicely.
Good guess, but no.
Okay.
The head was still moving around, eating algae, its preferred food.
Okay.
Which is
Sure,
pretty
why
weird,
not?
but sometimes creatures do move and kind of act alive for a while, even after they're dead. And Mito expected the slug to die, as you might, but that is not what happened. The head continued to eat, and it quickly healed its wound, and then it began to regenerate its own body.
Nice.
Now, mind you, it had lost its entire body, including its heart, intestines, and kidney.
Okay, that's crazier than I was expecting.
That's
Okay.
awesome.
Yeah, that's so cool.
It regenerated its heart in a week and its entire body in about 20 days. Meanwhile, the body, which had been
moly.
detached, survived, and this is a quote from the paper, reacted to physical stimuli, which I read as it twitched when you poke it.
Yeah, that's what I was picturing. What happens when you poke it?
I mean, that's a good hey, that's how science works. You write it down in fancy terminology, but the actual experiment is you poke it with a stick.
Exactly.
Right.
So it actually, this body kind of, just like hung out for days to months. It didn't regrow a head or anything, and eventually just kind of shrank and atrophied and decomposed. But the heart kept on beating up until the last moment. Okay, so it is pretty common for animals to shed a body part, especially to escape from predators. This is called autotomy. And there are many species that can regrow a body part. Earthworms are famous for being able to regrow. Actually, not both halves of the earthworm will regrow, just the larger piece. It's a misconception a lot of people have. Lizards are famous for being able to drop their tails. But this is the first known instance where an entire body has been regenerated from the head.
Yeah. Yep. Hold
That
on.
is
Let me
something.
grow a clone. Hold on.
Yeah.
I
This
seem
would
to
have
have
made-
lost my head.
Okay.
This would have made the French Revolution much trickier.
This is gonna. Damn it! We just took off Robespierre's head, and now he's back on his feet again. This gets weirder, though. Another thing I had not mentioned.
You don't say.
Yes, the Alicia did this to itself.
What?
Wait, what?
Yeah.
It cut its own head off?
It cut its own head off. Mito and her colleagues started watching the slugs to see what was going on, and they observed this behavior in several other individuals, all members of two different species in this genus. So it's Alicia marginata and Alicia atroviridis. Okay, so not all of the slugs decapitated themselves, but many of them did over the course of the observation period. And not all of the ones that did this survived, but the younger the slug was, the more likely it was to be able to regenerate successfully. But these slugs have basically a groove around their neck that appears to be what they call a breakage plane. So it's basically an area of the body that's designed to break off cleanly. Lizards have these in their tails, for example. Okay. This is obviously different because a sea slug does not have a backbone the way a lizard does, but it's this kind of analogy. So why would they do this?
Yeah, why? How?
Right, yeah, what's the advantage?
What's causing them to do this?
They don't know for sure, but they have a pretty good clue in that all of the slugs that decapitated themselves had internal parasites.
Oh, wow.
And the ones that did not self-mutilate mostly were parasite-free. And the regenerated bodies were parasite-free.
That's fascinating.
Yeah, and these parasites these slugs have actually interfere pretty strongly with their reproduction. So even though this is a high-risk behavior, because not all of them survive, the rewards must be pretty high. And a reproductive advantage could be.
That's awesome.
Yeah. So that's really fascinating. The other question that may be occurring to you is, how is this possible that the animal could survive so long without all those really important parts of its body? I mean, a leg or a tail, even an eye is one thing, but your heart, right?
Bit of a fingertip.
Yeah. bit of a fingertip. So a key feature of these two species that I have on purpose neglected to mention until this point is that they can photosynthesize.
What?
Oh, nice.
Yeah.
That's crazy.
They do something called kleptoplasty, which means that they quote unquote steal chloroplasts from the algae they ate. Chloroplasts are the little subcellular organelles that create the food for plants from sunlight.
Oh, wow.
And they have a very finely branched digestive organ that it kind of filigrees out to most of their body. And it's lined with these special cells that could host the chloroplasts and let them survive for a really long time. So basically they're being, at least for a while, sustained by the food from these symbiotic chloroplasts that they've stolen from the algae that they eat.
So they're like farming chloroplasts inside their body.
Yeah, basically.
Oh my gosh. That's so
like
cool.
The chloroplasts are above that breakage plane? So
they're throughout the body.
Everywhere, yeah.
Okay.
Yeah.
That's insane. Whoa.
Very cool.
That's all I got on those, but I feel like that's enough.
I'm going to be thinking about this for a long time.
Sea slugs are so cool. Or, sorry, you called them something else.
Wonder mollusks.
Wonder mollusks are wonderful. There's so many cool facts about them. I had not heard about this. This is fantastic.
Yeah.
That's so cool.
Thank you for sharing.
You are welcome,
Victoria.
And we will see all of you next week.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.
So this is a book about Alaska, which is fascinating. I highly recommend it. It's called Coming into the Country by John McPhee, and he's spending some time with a family that lives way off the grid in the bush in Alaska. The woman of the house, Betsy, says for years she kept a diary of the meals the family ate. Grouse, which she hunted with a .22, occasionally appeared in it, and beaver, lynx, mountain sheep, grayling, and pike, not to mention king salmon. But the main staple of the house was always moose, as a flip of the pages reveals. These were the features of consecutive winter nights. Spaghetti with moose burger, moose steak, omelet, moose steak, moose roast, pinto beans and cabbage, toasted cheese sandwiches, moose stew, moose meatloaf, leftover moose, sandwiches, spaghetti with moose burger, Swiss moose steak, leftover moose, roast moose, moose steak, moose sandwiches and soup, moose burgers, clam chowder, fried moose liver, Swiss moose steak, ground moose and Spanish rice.
Swiss moose steak?
Looking up from this list, when I read it, I asked her, "What are we having tonight?" "Swiss caribou," she said.
That's awesome.
Hold on, I gotta shift.
Shift. Okay, good. I wasn't sure if, yeah.
Oh,
sure
no,
what
I
you
didn't
said there.
swear.
Shift, she said. Good.
Shift.
Oh, shift. All right, you're up.